started, just in the interest of time, I'd like to say hello and welcome you to our Age Well webinar today. My name is Alison Schneider, and I am the Education and Training Manager at Age Well, Canada's Aging and Technology Network. In today's Age Well session, choosing a commercialization pathway for your innovation idea, we will identify 3 commercialization pathways for academic researchers. We're excited to partner with Simon Fraser University's Invention to Innovation program for this webinar. Our speaker, Dr. Jon Thomas, is the Acting National Academic Director for SFU's Invention to Innovation program. He is also a BC Regional Innovation Chair, the Director of the Esposito Family Centre for Innovation and Entrepreneurship at the University of the Fraser Valley, and an Associate Professor at UFV's School of Business. So Dr. Thomas plans to speak for about 45 minutes today, or enough time so that we have that 10 to 15 minutes afterwards for Q&A. So please post any question or comments for the Q&A in the chat. You'll also see the Q&A box, and you can do that at any time. At the end, if you want to raise your hand to ask a question verbally, you may do that as well. This is your chance to develop a better understanding of commercialization, so please don't hesitate to ask any of your questions. As mentioned, this webinar is being recorded and will be available for replay on the AgeWell members intranet, and I will send that link to all registered participants as well. Okay, so that's it for me for now. Without further ado, I will turn it over to Dr. Thomas.
Thank you very much, Alison, and thank you to AgeWell for inviting us and the I2I program to partner with you for this webinar. Let me begin first by acknowledging that I'm joining all of you from the ancestral lands of the Stalo peoples, and I'm privileged to live and work on these lands. Let me now share my presentation. Is it visible to all of you?
That looks great. Thank you.
Perfect. So today we are going to be looking at the commercialization pathways that you may have for your innovation ideas. And so broadly, my colleagues and I have over the past many years, more than a decade, been looking at science commercialization, particularly emerging from university settings. And what are the challenges in those processes, and what are the opportunities, and how can science commercialization truly contribute to society? Because that seems to be one of the driving motivations for the scientists and engineers and clinicians that we have spoken to over the decades, is that they are really driven about seeing their research in action. They are really driven by seeing how, or exploring how their science, their research can contribute to society. And of course, they are also very much driven by how to better support their students and their lab members. So with that intro, let me now take you to a time that perhaps all of us remember when COVID-19 emerged in Canada. And here is some news that we look at from British Columbia, which sort of in March of 2020 highlighted how schools were to remain closed indefinitely, courthouses closed, gatherings closed, and people were really advised by various levels of governments how to stay at home, how to have these very small bubbles and not to interact too much. And this was a period of exceptionally high levels of uncertainty in society. It wasn't clear when we would emerge from the pandemic. It wasn't clear whether we had some solutions. And all of this was quite a challenging time. Now, fast forward a few months ahead, in November, we see a notification from the US Food and Drug Administration giving out to Eli Lilly about emergency use authorization for a drug called bamlanivimab for the treatment of COVID-19. So treating those who had got COVID-19, here was a potential solution in case you do get admitted to the hospital with COVID-19. Now, why do I pick up on this case? The reason is twofold. One, it showcases how quickly our scientists were able to adapt and how quickly the regulatory system responded, and perhaps also highlighting what is the Canadian connection to this development. This was close to a world first, one of the first in the world to develop a solution to address severe cases of COVID-19. Here is a quote from the research from the report of the advisory panel of the Federal Research Support System in Canada for 2023. As the global pandemic and the rapid discovery of health solutions made abundantly clear, the patient and determined investigator-initiated research activities that have unfolded through decades can be marshaled seemingly miraculously in a matter of months to answer a pressing need. And so here I emphasize this part about how decades of research capabilities that were built up over long periods of time, how they were adapted, refined, reformulated to address a highly complex challenge. And that is the case of the company that we look at from the Vancouver region, from the Lower Mainland, a company called AbCellera, which was partnering with Eli Lilly. AbCellera was the company which was able to identify some of the therapeutic antibodies in a very, very record or a very short period of time, which was then taken forward and scaled up by Eli Lilly, which is the much larger company and partner. So there is a Canadian connection to some of those first solutions to treat COVID-19 in the world. And now when we did a paper looking at AbCellera, we realized that this was perhaps a 20-year overnight success. And a lot of the reason for this rapid translation was because of the capabilities developed in the research lab, sometimes more than a decade before venture formation. And so we mapped out how Carl Hansen, who's the founder of this company, what his PhD was on, what were the key papers, what kind of learnings and capabilities he had developed in the lab of his supervisor in Caltech, and how he joined the University of British Columbia in 2005, with the venture actually being formed in 2012. So for a period of 6-7 years, even when he was a PI, he was getting a number of grants from NIH, from Genome Canada. He was exploring co-founding ventures with other collaborators like Professor Peter Cullis from UBC. And then finally, AbCellera was founded. And the AbCellera's technology was really extremely valuable. And at one point, they had received grants from the Gates Foundation, grants from DARPA, all of which then left them or prepared them well to pivot and to address the challenges thrown by the pandemic. So the point from this slide here, which is published in one of our papers, is how entrepreneurial capabilities are developed and refined pre-formation, many years before science-based venture is incorporated. All of that plays quite a critical role, not just in the survival and success of these ventures, but how these ventures might pivot in the face of unexpected challenges facing society. So it was this paper in Nature Nanotechnology where we looked at the rapid response through the academic capabilities, through the entrepreneurial capabilities of academic scientists, who can make path-dependent decisions that enable universities and university spin-offs to rapidly respond to global crises. And ventures, from a lot of our research, what we've realized is that science-based venture formation may not be the only pathway to societal impact. There are other pathways. So if you look closely at this figure, often the period people coming in for training or training on entrepreneurial capabilities or training on business as scientists. So these scientists would have spent many years doing discovery research, many years in their research labs, and then they may come into these pathways. And often many programs, and we've compared, we are in the process of coming out with a white paper which compares a couple of leading programs across the US, the UK, and Canada. And we see many programs focusing on the science-based venture pathway. And yet we also would like to emphasize that along with the venture pathway or forming a science-based venture, you can also be a translational scientist in academia. And you can also be an innovation champion in industry where you work in existing companies and help them innovate better. So your understanding of entrepreneurial capabilities, your understanding of how science and business can be combined, all of that make you particularly valuable to industry. And let me now delve deeper into what I mean by translational scientist and some of the longer-term impacts of translational scientists. So here is a study my colleagues and I published in a journal called Technovation. What was interesting about this study was we followed one star scientist who had founded over 30 ventures over his academic career, over a 40-year period, and matched 363 of his co-invented US patents to more than 1,400 co-authored publications, and matched these patent paper pairs to each of the ventures that he had co-founded over the 40-year period. And the reason why we chose one particular scientist, of course, was due to his exceptional productivity, which is again, 30 ventures, 1,400 plus papers, over 400,000 citations, 360 US patents issued at the time. And I'm sure some of these numbers are quite higher now. And the patents were licensed to over 300 companies. The translational scientist's name is Professor Robert Langer. He's from MIT. Now, what I need to emphasize here is that science at this stage, and particularly in Bob Langer's lab, is a team-driven activity, in that it is Bob Langer, it is his faculty collaborators, it is his students and former students across multiple universities who collaborate extensively on a large number of projects. And that is how this impact has built up over 4 decades. So some of these numbers are quite unusual, and yet there is, when you look at it over a period of time, there is a method to this level of output, and that is what we sought to uncover. How is it that in a domain where starting even one science-based venture is quite challenging, how was an academic scientist from a university setting, how was he able to form so many ventures and create so much impact? Several of those ventures have developed technologies that have been incredibly useful for patients. So the methods that we followed was we did an inductive case-based model on the role of the star scientist in the commercialization process through university spin-offs, matching these patents with the papers that he was a co-author on, matching patent paper pairs to 30 ventures. This analysis was followed by extensive interviews with the MIT Tech Transfer Office, with other co-founders, CEOs of his some of his startups, to get a more comprehensive view of this science commercialization phenomena, and through the case of an outlier. And so what I want to emphasize really is that university spin-offs or science-based venture formation emerges from the research lab. So what goes on in the research lab is critical. And what goes on in the lab well before venture formation is incredibly important. And so what aspects of that are important, and how does this process evolve, is something that this paper shared. So one of the key components of our understanding of Bob Langer's lab was, he starts off with technology market matching in the selection of research projects and in the selection of who to assign to which project. He and his team are always keeping a close eye on what are the big problems facing society, or what are the big problems facing specific industry sectors. And that leads them to formulate a research problem in a manner that it is scientifically rigorous, can be published in elite journals. But if that problem can be solved in the research lab, that solution is valuable to society or to industry. So it is in the process of formulating your research project that you would need to incorporate or have an understanding of what might be the potential target. What are you working towards? So that is one aspect of it. The other aspect is to try and match once this project is formulated, try and match that to various disciplinary perspectives and collaborators, and bring them together. Then we have the Tech Transfer Office playing a role in supporting, claiming, and protecting these inventions through intellectual property management and filing of patents, attracting and mentoring the founding team once the research reaches a certain stage, to try and figure out how the entrepreneurial venture can be formed. And then strategic timing of formation, which is really understanding the distinction between what is useful as a lab result or success in the lab versus what is useful as success in the real world. Sometimes there's a big gap between lab scale versus commercial scale, and even that scaling up takes quite a bit of time. So I'll quickly get into some of the more specific examples of how this process flows. So let us look at technology market matching in a little bit more detail. So one of my colleagues, collaborators, provides this very useful example of how you might look at glass and various types of glass, which might have applications in the automotive industry, in the aerospace industry, or you might have applications in other sectors. And you find that technologies are sometimes platform in nature, in that the technology can be adapted towards different industries. And so when you're starting to form a technology venture, one of the common or most common challenges is that you don't have all the resources you need to target all markets or all industry applications for your technology simultaneously. So you need to prioritize which industry or which market application will you go for first. And that aspect is critical, and that aspect is technology market matching. Which industry will you focus on first? And that's a very careful choice to be made. And that is one of the things that we really emphasize in the Invention to Innovation program, is getting you to think very deeply about What is the stage of development of your technology? What are the regulatory barriers in the market that you seek to target? What are the options that you have? Are there some markets that you may choose to focus on now and some that you may want to focus on later? All of these choices are explored in a lot of depth. Uh, to give you an example of a platform technology from the Bob Langer lab, we look at controlled release polymers. And so this technology of controlled release was developed by him in the mid-70s, early 80s. And then his first company was a company called NZ Tech that he started very early on. And as you note, these were micro or nanoparticles. And from 87 to 1993, he started another company called Accusphere, then a third company in 2006 called Bind Therapeutics with a former postdoc who's now at Harvard. And then we had a couple of other companies over the years. Then the same principle of control release was also explored using ultrasound, which led to another company called Sontra Medical, and through aerosols through a company called Air and Palmatrix. So you see the same underlying technology was then commercialized through multiple different ventures. Now here I say this is an example of one platform technology. Let us look at the case of how he started his 30 plus ventures. So you notice controlled release here, but Langer also, along with his collaborators, worked in tissue engineering, which again is a platform technology with a couple of ventures started over the years, enzymes, biodegradable polymer devices, informatics, polymer coatings, diagnostics, and so on. So all of these are indicators of how these collaborations span decades and really lead to impact. And the learning from one venture can inform the choice of ideas or markets for the next venture a couple of years down the line. So that is how risk is sort of divided and specific market applications are focused on. Now let's quickly look at claiming and protecting the invention. Some of the challenges we often have is, well, as a university staff member, employee, researcher, we are encouraged to share ideas through publications. How does publication and patenting work together? So typically you would file for a patent first, and then submit your paper so that there is some intellectual property protection. Star scientist entrepreneur like Bob Langer focuses typically on platform technologies, publishing papers in elite journals, filing early broad blocking patents, and developing their licensing strategy with the tech transfer office. So typically tech transfer offices, some of the perspectives that they have is you're impacted by your school's bandwidth and ability to support this process. Their focus on maybe specific industries to support you on how to and guide you on how to file patents on stuff that may be more high risk. Asking questions like, are you sure? Do you want to give all the rights to one company? How about dividing the rights by fields of use, by jurisdiction, and so on? Asking questions like, can you patent early and broadly? Can you envision as many different industries and applications your invention might enable? How can you patent and license in such a way to enable several shots on the go? How can you patent in a manner that it aligns with alliance partner incentives? Because at some stage you will need to have partners, particularly in the biomedical domain, where startups often work with much larger companies as they are scaling up or getting acquired. In terms of the third entrepreneurial capability, so you remember the figure, we started with technology market matching, then we had claiming and protecting the invention, and then we have the attracting and mentoring the founding team, which is the third entrepreneurial capability pre-formation. All of this is happening before the venture is formed. As the venture is being formed, What is the role of this PI or star scientist? Typically, they, like in Bob Langer's case, he chooses to play an advisory role with his lab alumni joining the company in roles like the chief scientific officer or supporting the chief scientific officer. The business experience is brought in by venture capitalists or people from multinational companies, large companies, or those who have started science-based ventures before. And the roles that they take on are that of president, chairman, or CEO. So this is a way in which the experience of scientists is blended with the experiences needed, with the experience needed to get a business off the ground. And the PI from the academic lab plays more of an advisory role, sharing their skills, expertise, and credibility, because often in the very early stages of setting up a science-based venture, no one knows about the venture. So their understanding of a venture is driven to a large extent by who are their advisors and what's their track record like, both scientifically and in science commercialization. So there is this liability of newness is a term that is used, and therefore there is some signaling. And for those from the management domain, there is a signaling literature which speaks to how science-based ventures and startups can signal the value of their technology to potential investors. And then finally, as these founding teams are being developed, it is also really important to remember that there is an element of timing to when you form a venture. If you form your science-based venture, incorporate it too early, you may still be far away from market applications because there might be regulatory hurdles. You may not have fully developed your founding team. You may not have raised up all the financing you need. Many of those processes may be partially completed. You may therefore be misaligned with investor timelines. Typically, many science-based ventures need to raise additional funds. And when they do, these investors from whom the funds are being raised, they are looking to, I should say, support for 3 to 5 years. Sometimes, if you're lucky and everything matches, about 7 years. So the expectation really is that investors are looking to exit in about 3 to 7 years for the most part from these ventures. And yet, given the scientific uncertainty, given the market uncertainty, given the regulatory uncertainty to some of these sectors, you may often have a situation where the science is moving forward, but you don't have a product that you're selling. Revenues are not coming in, and investors are trying to figure out a way to exit. So there can be an exceptional level of pressure if you found your venture too early. And what also happens is a nuance is that once you form a legal entity, you are seen as different from the university in a way, in that now as a separate legal entity, if you're using university resources, then it can lead to a little bit more challenges, and thus you may lose sometimes university incubation supports. That can become a challenge, or even if you don't lose supports, you may have to pay more than you typically would have had you not formed a venture. And here, the reason why we focus on these entrepreneurial capabilities and emphasize how much work has to be done before forming a venture is because this is an excellent sort of depiction of the challenges. In that science-based ventures, the commercialization cost is pretty high compared to, say, information technology, IT-based e-commerce kind of ventures. The time to commercialization is very high. The level of uncertainty is very high. And the cost to commercialization, as well as the R&D costs, are typically high. All of this leads to the need to plan better. And that is what programs like the I2I, as well as this emphasis on pre-formation entrepreneurial capabilities, try to get scientists to do, is thinking well before and planning. And once the venture is formed, again, I get back to the case of Accelera. where we talk about Abcelera partnering with a large number of nanomedicine companies, typically nano, like for example, lipid nanoparticle drug delivery companies. They would again have high levels of uncertainty, lots of R&D and commercialization costs. Abcelera's antibody discovery technology allowed them to partner with these typical nanomedicine ventures and helped them to lower their uncertainty and reduce their costs. So it was a win-win deal for many nanomedicine ventures and partners. So Abcelera, when it started for the first decade, I would say had a large number, over 100 or possibly 150 partners with which they have been working. And while they have been doing that and generating some revenues, they are simultaneously also building their own GMP lab facilities for manufacturing and moving their own product line. So this is one approach to manage some of those uncertainties, partner with companies, and try to bring down the costs and develop your own pathways to revenue generation. All of this happens, and again, I focus on that planning part and how much planning is needed. Is in this case of Bind Therapeutics, which is from the Langer Lab, we see that the venture was founded in 2006, but a lot of that research was going on. Some of those early patents that Bind relied on to get additional funding from VCs, which is Series A funding of $2.5 million, Series B funding of $16 million, Series C funding of $23 million. This funding or these kinds of funding were unlocked because of the intellectual property underlying the technology. And that IP had been granted, some of that initial IP had been granted in 1996 and 2003, well before the company was actually formed in 2006. So all of this sort of substantiates the sort of perspective that you need to have done a lot of work and have developed your IP portfolio and work towards building that founding team. Even then, you can run into challenges when, as in the case of Bind, when you're doing that manufacturing scale up. So there can be some challenges. This is also published as another case study paper in Nature Nanotech. Again, I get back to our figure to show technology market matching, claiming and protecting the invention, attracting and mentoring the founding team, and the strategic timing of firm formation. And how the university TLO, the patent office, academic collaborators, experienced executives, and venture capitalists, all of whom come together to support this process at various stages. But the locus remains, for the most part, in the research lab with the PI and lab members. And there is a reason why I use these terms and use these foci to get you to think. Research labs across the world have intangible assets. This would be academic co-founders, human capital, research excellence. They may, in some cases, have intellectual property in the form of patents. They will have social capital in the form of national and international research networks that they are part of. So this is typically available, or these intangible assets typically exist in many research labs. When combined, or when we use entrepreneurial capabilities, training of technology market matching, claiming and protecting the invention, mentoring the founding team, timing firm formation, when you leverage these intangible assets with entrepreneurial capabilities, you can form university spin-offs, which are better positioned for success, which are better able to handle the market uncertainties and regulatory uncertainties. So that is why we see in the I2I, we see the critical role of entrepreneurial capabilities training to leverage the intangible assets that exist in most and many research labs across the country and across the world, really. Now, keeping that focus on the research lab and how central it is to the process of science commercialization, in a recent study that we did, where we asked university administrators, PIs, postdocs, program directors of people developing programs to support postdoc training on commercialization, one of the things that emerged is captured in this quote. One of the things that we recognized is that in most of the cases of technologies being transferred out of universities, the people that were key to that process were postdocs. And there is a reason for that. Typically, when we look at the academic setting, PIs in many institutions may be more incentivized to focus on their research and teaching and less incentivized to focus on commercialization. When we look at undergrad students, graduate students, they are typically incentivized and guided to focus on their courses, exams, theses, dissertations. And so that leaves, when you look at the research lab, that leaves postdocs as the group which will, who have passed the doctoral process and who have a little bit more flexibility to engage in commercialization activities. The challenge often, though, is that the status of postdocs in many institutions is a little bit fuzzy, but some of that fuzziness can work to their advantage in that with the buy-in of their PIs, they may be better aligned, or they may, if they choose, focus on commercialization processes from these labs. And yet, in recent editorials, postdocs in general are facing a lot of challenges. I was a postdoc myself for a number of years before getting into a faculty position. Postdocs are typically, their positions are fragmented year from year. There's a lot of uncertainty around the kind of funding that they get. Only few postdocs are able to secure the tenure track positions that many people seek. And this is also noted by many articles and studies, and which emphasize that postdocs would be better prepared for non-academic positions, which would highly value their skills if they also had entrepreneurship training. So particularly in Canadian academia, over 80% of Canadian HQP do not get academic jobs. There is low receptor capacity in industry because there's a mismatch between the capabilities that industry needs, which is science plus business, to the capabilities that many scientists bring, which is very in-depth science focus. The training may be inappropriate or unavailable. There may be underinvestment in commercialization skills and strategy pre-founding, so well before venture formation, or well before even a decision is taken. Should we start a venture, or should we license out that technology to industry? Increasing recognition that researchers must be engaged and trained to make this translation to impact, because there is a lot of work and specialized work that needs to be done in the lab, and there's a lot of work that needs to be done outside the lab to get that technology out to market. And there is unequal socialization and access to commercialization and translation skills. So these skills are not equally available across institutions or regions, or to people from different industry sectors or disciplinary backgrounds. And existing supports are not necessarily made for translational paths and stages. All of this is mentioned in a couple of reports, which highlight some of these challenges. And so the case being made here is that there are significant postdocs are uniquely positioned to contribute significantly to science commercialization. Yet for the moment, there are some gaps in training, and with that training, postdocs may be better prepared to contribute back to their research labs. Postdocs may be better prepared to take and make an informed choice on, do they start a venture with the technology that they are working on? Do they want to try and walk on the translational scientist pathway in academia, where they start their own labs and work like Bob Langer did? Or do they join established companies in industry, but with a combination of skills, science skills as well as business skills? And thus you have entrepreneurial capabilities which enable well-endowed spin-off formation through the scientist entrepreneur path, increasing science-based innovation in industry and Canadian industry by developing champions of innovation. And in many cases, people who have graduated from the I2I program have gone on to join in innovation intermediary organizations and helping set the base and trying to provide, so working with tech transfer offices, working in policy, working in domains which are not just traditional industry, but an expanded definition of industry and industry support organizations. And finally, of course, the translational scientist pathway in academia, which is a longer time frame endeavor, wherein you focus on commercialization in your lab through focusing on platform technologies, but you also build and expand your own research team so that, like Bob Langer and Peter Cullis, in time, not only you, but your grad students and postdocs also walk these pathways and also have these options to contribute to society and serve grand or address grand challenges. So finally, what are the takeaways from this talk? So commercialization pathways that I talked to you about, the three commercialization pathways: one, translational scientist at a university or in academia; second, industry innovation champion who works with existing industry and helps translate university research and get it adopted in established industry; and finally, the more common process that's commonly known, which is that of forming science-based university spin-offs. All of these operate, and the lens to look at is science commercialization has higher levels of uncertainty and much longer timelines. All research labs have intangible assets that can be leveraged through entrepreneurial capabilities. This entrepreneurial capabilities training is needed for STEM postdocs and graduate students. Early stage technology market matching, when you are forming a venture or when you are forming a research project, more importantly, when you are formulating a research project, early stage technology market matching is exceptionally valuable. At the stage of venture formation, focusing on strategic timing so that you're aware of investor timelines. Understanding that taking these kinds of entrepreneurial capabilities training also needs buy-in from your PIs. And for PIs to support this process, as well as in-kind commercialization supports that could be provided by the host institution through through the research lab, access to facilities, access to mentoring, all of that can be provided by host institutions. For policymakers and funders, I think what's an emerging perspective is that in-kind matching is much more appropriate than requesting or asking for matching funding requirements, because a lot of the time ideas can get stuck because PIs or grad students are unable to find an industry partner or a partner who can provide those matching funds. So ideas can languish in the lab, just waiting for that matching funding. And even when you might get that funding for a single year, you might have your partner's priorities changing after a year or two, which then is not conducive to getting these ideas, impactful breakthrough ideas, out from universities into society. So the emphasis really is training is needed for STEM postdocs and graduate students to navigate this path well before they decide which of these pathways they want to follow. So with that, I'll give a quick plug to our Invention to Innovation program. The 2024 I2I application deadline is May 28th. That is 2 weeks from now. The link is provided, and Alison will also share the link in the chat with you. There's a streamlined application which asks for your innovation idea. What technology are you working through? The I2I program, one of the unique aspects is every course you continue working on your own idea. So you can, through each course, you refine your own idea. And so by the time the program ends, you have a much better understanding of what might be that first market that you might seek to target, what could be potential challenges, and how can you be better prepared. All of that work can be done well before you decide to form a venture, or you decide to develop the IP and license it out to industry. All of this work is done with a large number of collaborators. First and foremost among them is Professor Alicia Main from Simon Fraser University, who I've had the pleasure of working with for more than a decade now. And so the papers, all of which are hyperlinked here, are in a collaboration with all of these collaborators across Canada and across the world. With that, I'm happy to take questions and look forward to discussing this very exciting topic with you.
Great, thank you so much, Dr. Thomas. I just put a link as well to the information session that's happening on May 23rd. So if you are looking to apply, that would be a really important session to attend. So that Eventbrite link is there. Okay, so Dr. Thomas is available to answer your questions. I feel like I'm on a radio show when I say it like that. But if you have any questions, you can post them in the chat, you can post them in the Q&A, or you can raise your hand. You can use that icon on your toolbar there to raise your hand, and you can ask a question verbally, which can sometimes be easier than writing out all of the details. So we're available for the next 10 minutes or so. We can have a chat about some of these processes. There's definitely overlap with what AgeWell has supported, right? With how we encourage academic researchers, trainees to think about industry and that pathway. Because as you said, the timeline can be significantly different and those skills can be leveraged, but of course, folks need training. So would you mind telling us a little bit about I know you have a training program as well outside of the regular application. Can you tell us a little bit about that?
Yes, for the I2I, we have a couple of ways in which we provide training. So at the moment, we have started what's called the graduate certificate, which follows the Invention to Innovation program. So there are 4 courses of 6 weeks each in the Mitacs I2I program, which start in September 2024. These courses are asynchronous, one after the other, and at the end we have a national event where finalists are chosen. This year we completed our finalist was selected on May the 3rd. It was a PhD candidate from Montreal, and she was developing an exoskeleton for children with walking challenges, so some kind of ankle exoskeleton. I have also to the age-old community. I have worked with students who have been working on technologies to assist with bed sores, or older people are often in hospitals, or often on hospital beds, or even stretchers for long periods of time, which is quite unfortunate. And so that bed sores are quite a challenge. So you need some kind of pressure sensors which can help identify the potential to develop bed sores before they actually occur. And so I have worked with one of our students who's been developing some technologies to address some of these issues, more from a aging perspective. And so there are all of these ideas which there is a technology problem to be solved, then there is a market problem to be solved, and then there's a regulatory problem to be solved. And of course, all of this in the background, there is how do we pay the bills while we do all of this? And particularly because these technologies are not yet on the market and revenue streams are difficult to build. So how do you convince investors that the technology has legs and people should keep funding you? So it is a challenge that requires significant planning, and it tends to help.
And the support, right? You need that community of support.
Yes.
Takes a village. That's
For
for
sure. And that's why we have both the national cohorts across the universities like University of Waterloo, University of Alberta, our new joinees right now. We also have cohorts at Queen's. We have a French cohort. And of course, West is strongly represented over the years. We have been funded over the years by Mitacs, who've been a significant and valued supporter of this program. And these positions are funded, so students typically there are funded seats where Mitacs is the funding agency, and as long as someone has a good idea and they are interested, this can be quite a valuable experience. The network also provides not just these cohorts where you realize that you're not alone. And there are many like you, and that is many of us as scientists and researchers are quite comfortable working on our laptops and devices and in our labs, more working with ourselves or in small teams. But when you're talking about commercialization, often you might feel as if you're the only one exploring it in your lab. But when you look at this national community, you start seeing perspectives, or you start your thoughts being echoed by other people, maybe from different disciplines, but facing the same challenges. That is incredibly useful and valuable and supportive. And secondly, part of our network is also a strong group of industry mentors, because at a certain stage, you need that industry perspective and contacts to help you test out your ideas, because you don't want to be spending 5 to 7 years of your life and having raised a lot of funding for which you have to answer, and then realize that actually not many people are interested. And that is something that happens not just to science-based ventures, but even to other non-science ventures too. And that is something we try to head off, is very early on, if you're interacting and trying to get a sense, okay, who is that person who's going to pay for it? Who is that person who's going to benefit from it? If you are very clear about that, then you can visualize that endpoint. What are all of us working towards? And that sometimes in the case of science commercialization is not an easy question to answer. It needs some work to find whose problem are we solving.
Yeah, integrating some of that business thinking, right? The marketing, doing that sort of assessment of what's already out there. One thing we also emphasize is co-researchers, right? Bringing in people who would be your end user to give you feedback, to help you to understand what exactly is needed in the marketplace. Do you talk a bit about that as well with some of your programs?
Yes, so we would like one of the examples that I didn't delve into deeply in due to the time is I'll give an example from Bob Langer's lab is that there was a problem in mid 80s, early 90s in the pulmonary drug delivery sector, in that it's very difficult to get drugs to reach the inner recesses of the lungs. And so a lot of technologists have tried working on it from their disciplinary lens, and it wasn't working out. And then Bob Langer gave this problem to a mathematician, which was quite unusual in that, well, let's have someone look at it in a very different way, and let's see what they come up with. So after the analysis, what the person came up with, the postdoc Dave Edwards, was that, well, what you actually need is a large particle that is porous and that can float into the lungs. And that large particle, because it's porous, you could fill the drug inside and then it slowly seeps up. And then they found a way to actually do it, and that technology was quite useful. The company was quickly acquired by a much larger startup for millions of dollars, a much larger established company for millions of dollars. It was called Advanced Inhalation Research. So if you and that was just one of the companies in that big graph of 30 companies that I showed, big figure. So there are examples like that where sometimes the perspectives of someone from a very different disciplinary domain can add incredible value to the problem you seek to solve. And so if one of the aspects of the I2I is developing that comfort, and one of our instructors and regional leads has put it very nicely when he says that you can either think of yourself as stepping outside your comfort zone, or you can think of yourself as expanding your comfort zone, in that you can take in more and you can be open to more kinds of ideas. So we would like to think that the I2I allows you to expand your comfort zone and walk between the worlds of academia, industry, and startups.
That's awesome. That's a great quote. It's all about your perspective, right? And sometimes you need that in order to break down those mental barriers that we have for ourselves as well. Well, I guess it's time to wrap things up. Our audience wasn't that chatty today, but I'm glad that we got to have a great conversation. I know folks are still here listening in. So, oh, a last minute question. Do you have a minute? We might
Yes.
go a little over. Okay, so we have a question. The examples described here are very much NSERC focused innovations. As my business idea is more CIHR relevant, specifically leveraging existing technologies to provide better evaluations of individual health, is the I2I program the right fit?
I would say that we've had a couple of clinicians, and we've had people from different medical backgrounds also taking the program. So we've had that. Over the years, we regularly have people coming in with these kind of backgrounds. Often what I will say is that when we look at the CIHR or health or biomedical sort of domain, the complexity tends to be even higher. And the complexity is at multiple levels. One, in that you have to get the technology through regulatory approvals, which of course you develop the technology, you find the market for it, you get the regulatory approvals, and then you have to make sure that, particularly in Canada, it is procured by health authorities or health agencies, because that's the way things are structured in Canada for the most part. So you have to have a very nuanced approach to getting some of these technologies adopted beyond just developed and getting approval for, getting them adopted by the Canadian healthcare system can be its own challenge. And a case in point, again, Abcelera, the technology was developed in Canada from a lot of the lipid nanoparticle research from Peter Cullis's lab in University of British Columbia. And yet it was the United States that first started using Abcelera's technology, and it took more time for Canadian authorities, and Canadian authorities are more cautious, more risk averse, and that's just the nature of how we are organized and what say entrepreneurs or scientist entrepreneurs have to work with. So to answer your question, yes, the I2I program has had a history and has I have worked in biomedical, biotechnology, commercialization. One of the other things that I had done when I was a postdoc was I was supported by the Center for Drug Research and Development out at UBC when I did some of that initial work on the Langer lab. So there is some level of familiarity among the instructors with biomedical commercialization. So I would definitely characterize that we are open and supportive of CIHR type ideas.
Okay, that's great news. Yes, we have often told our interested startup folks, entrepreneurial folks, that sometimes, yeah, the American market is just an easier place to start. And that doesn't mean that it won't get to the Canadian market. It's just a little slower. Okay, so we've gone a little over. Thanks for sticking with us to the end. I'd like to thank Dr. Thomas for his really great webinar today. I'm sure we will be referring people back to this recording as time goes on. I encourage you all to check out that I2I application, see if it suits your needs. We do hope that you'll take advantage of that great opportunity. And thanks for attending today. We do hope to see you at our future Age Well events. We actually have one tomorrow. I posted in the chat that's talking specifically about funding, startup funding, but as Dr. Thomas said, you'll need a future plan. So there are a few webinars in this series that will help you sort of planning from a legal perspective. So that's what this one is talking about as well. Okay, so without more chats and more posts in the chat, I'm going to close things up. But thanks for everyone attending today, and I hope you have a great rest of your day. Thanks so much.
Thank you, Alison. Thank you for the opportunity.
You're so welcome. We're so glad to have you. Thanks again.
Thank you. Bye-bye.